Hello, welcome to Pythagorean Identities. What I'm going to do in this video is show algebraically where we get our three Pythagorean identities. And the first thing you need to know is the Pythagorean Theorem. Now, what figures does the Pythagorean Theorem apply to? Well, it applies to right triangles. So in our unit circle, or any circle centered at the origin for that matter, we know that if we go to a point on the circle, that's going to correspond to an ordered pair x comma y, where the x is the distance that you go over on the x-axis, and then the y is the distance you go up to the circle. And so this constructs a right triangle with theta at the origin, and we can calculate the length of the radius by using Pythagorean theorem. So our general formula for Pythagorean theorem is a squared plus b squared equals c squared. In this construction, we can substitute the variables x squared plus y squared equals r squared. So this is our foundation. This is going to be our basis for constructing the three Pythagorean identities. So we're going to start with the first one, which would be sine squared theta plus cosine squared theta equals 1. And we're going to show how we get that. So what I want to do is take this Pythagorean equation and I'm going to divide everybody by r squared. This is completely algebraic process here. So of course, r squared divided by r squared is going to give us a 1. Anything divided by itself is 1. X squared over r squared can be simplified to x over r quantity squared. Since both of those variables are squared, we can rewrite it as the entire fraction squared. And the same for y over r quantity squared. Now at this point is where you're going to have to know some basic trigonometric ratios. Okay, so the first one we need to know is sine of theta in any circle, not just the unit circle, but in any circle. Sine is y over r, cosine is x over r, and tangent is y over x. And so since we know that cosine of theta is x over r, then we can do a substitution and replace x over r with cosine theta. So that's going to give us cosine theta, and that is squared because the fraction is squared. Y over r is sine theta, so that's going to give us sine theta squared. And then if we reverse the sine and cosine, we're going to get our standard Pythagorean relationship involving sine and cosine. All right, so there's one of our Pythagorean identities proven. Now, why is it proven? It's because we started with something we know, which is Pythagorean theorem, and we did a logical algebraic manipulation to arrive at this statement, okay? Now, we're going to do the same for the other two Pythagorean identities, starting with x squared plus y squared equals r squared. And this time, we're going to divide everybody by y squared. Okay, so here, obviously, y squared over y squared, that's going to give us a 1. X squared over y squared can be simplified to x over y squared. And r squared over y squared, again, can be simplified to r over y squared. Now is where we need to know a couple of other trig ratios. Remember that the reciprocal function for tangent is cotangent. So cotangent theta is x over y, and r over y would be the reciprocal function for sine, which is cosecant. So cosecant theta is r over y. Knowing those two trigonometric Ratios is going to allow me to do a substitution and give me cotangent squared theta plus 1 equals cosecant squared theta. And so there is another one of our Pythagorean identities. And if you want to manipulate that, you can. If you want to say equals to 1, all you got to do is bring the cotangent squared over, and you can say cosecant squared theta minus cotangent squared theta would equal to 1. That is another way to write that particular Pythagorean relationship. And let's do it one more time for the other Pythagorean identity, starting with our Pythagorean theorem, x squared plus y squared equals r squared. And guess what? This time we're going to divide everybody by x squared. So did you notice that you can generate any one of these three Pythagorean relationships by simply taking your Pythagorean theorem and dividing by whichever variable you want, either x squared, y squared, or r squared. All right, here we go. X squared over x squared, that's going to give me a 1. Y over x quantity squared, and r over x quantity squared. And so this time, y over x, if we scroll up, we know that y over x is tangent. So this is going to be 1 plus tangent squared theta equals r over x would be the reciprocal of x over r, which is secant. Secant is the reciprocal of cosine. Secant of theta is r over x. And doing a substitution, that's going to give us secant squared theta. And so there is our third and final Pythagorean identity. And again, remember, you can isolate that. You can have it equal to 1 if you simply move the tangent squared over. So we can rewrite that as secant squared theta minus tangent squared theta equal to 1. And that's going to do it for this particular video, showing how we can generate all three of the Pythagorean identities using the Pythagorean theorem and the circle. So if you have any questions or comments, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.